Hello scientists. Welcome to this video. In this video, we're gonna be doing a mock review of your part 2. We already did the review for the multiple choice in class, and yesterday we all graded extended response, which is the part 2, and Mr. Pierre and I, we did a thorough data analysis of that part 2 to see the questions that you guys did the worst with. So this video is going to address those questions that you guys did the worst in for the extended response. We're going to be looking at 10 of those worst questions out of the 35 extended response questions in the part 2. 10 of them. In a particular order, just for easy understanding, I will take one question after the other, but all the questions that I'm going to be touching in these videos are the 10 worst question. So I'll begin with question number 59. So let's go to our question packet. Question 59. Question 59 here says describe the change in the length of a shadow cast by the observer at location B from sunrise to sunset. So we are looking at location B right here. Location B, and that is the observer, and is asking how the length of the shadow is going to change. Regardless of the observer's location, shadows change in length based on one principle. The lower the source of light, the longer the shadow would be. So when you look at this picture here, the first one right to your left, you see that the angle, the inclination of the light source, which is the sun here, the lower the angle, you see that the tree would have a longer shadow. And then when it's noon, at noon, the sun would be directly overhead, right on top. So there's no angle of inclination, it's just right on top. Okay, so because it's right on top, the shadow would be the shortest, very short. The shadow would just be right below you because the light source is above you. Remember, your shadow falls to the opposite side that the light is coming from. So you can see here that the light is coming from the left side, and then the shadow is being casted on the right side, and the shadow is long. At noon, however, the shadow is up ahead, overhead, so the shadow is just right below, the opposite way, and the shadow is very short because there's no angle of inclination from where the light is coming from. And then at sunset, again, now the angle has reduced because the sun is about going off, so the angle has reduced. So as the angle has reduced, it's going to get longer again. So simply put, at sunrise, shadows are long. At midday or at noon, shadows are short. Then at sunset, shadow gets long again. So from morning till evening, it goes like shadow gets shorter because it was initially long. So as you get into noon, it gets shorter and shorter and shorter and shortest at noon, and then start getting long again until you get to sunset. So simply put, the length of the shadow would decrease from morning till noon, and then after noon, the length of the shadow would start to increase. Or you can say, in the morning, the shadow is long. At noon, the shadow is short. At evening or at sunset, the shadow is long again. So your response should go something like that. So that is how we're going to answer question number 59. So let's answer that in our packet here. So I'm going to say shadow length will decrease and then increase, because in the morning, it's decreasing till noon. Or you can also say long in the morning or sunrise and short at noon, and then long again in the evening. All right, in the evening or sunset. Got it? Easy breezy. Next, question 63. Let's go. Question number 63. Identify one weather instrument that consists of a dry bulb thermometer and a wet bulb thermometer. Emphasis on dry bulb thermometer and a wet bulb thermometer. So these are two thermometers combined together. It breaks my heart that you guys struggle with this question because we literally did a lab on this. Remember, we went in front of the school building and we dip one of the thermometer, the one with the socks, we dip it in water because we said it's a wet thermometer, and then we swung for about 3 minutes and then we read off the values. So simply put, any weather instrument that has two thermometers and one of them is considered a wet thermometer and the other is considered a dry thermometer has to be a psychrometer, a sling psychrometer. That is the name of this weather instrument. Okay, so let's answer that question. Question number 63. We go to our extended packet and we move on to question 63. The answer here should be, I like using red because it's more obvious. All right, sling psychrometer. Easy breezy. Doesn't get any easier than that. All right, cool. Let's move on. Question number 65 is next. Question 65. Question 65 says, explain why the stream velocity and rate of erosion, of the stream bank are greater at location W than at location X. So let's look at that diagram together, shall we? So we see two locations there, location X and location W right there. Remember, this is like a simplified picture of this place or this portion of the earth. So if we were to zoom in, you will realize that this is actually a river flowing in that manner and flowing in that manner, and location W is right there and location X is right there. Now go back to your weathering deposition and erosion unit. We did explain, permit me to zoom in here a little bit, that when rivers are flowing and the river is meandering because it's getting old now, because the river has gotten to a more flatter land with a low gradient, so the speed of the river reduces. As a result of that drop in speed, the river begins to snake, and we call that meander. Because of that meandering, you see that the river at some point will be erode faster or move faster, and then at some other point will be slower. Now the reason is because as the river is coming through and flowing downward, the speed of the water will be higher and hits that part of the riverbed or the bank of the river, and then bounces off and then changes direction this way, and then as it goes further with the same speed, it's going to hit this area more, so it's going to cut from that area, causing erosion on that part, and then it's going to continue and then bounce off and cut here or cause erosion here. So simply put, wherever the river is facing head on, that's the part of the river that experiences the erosion. The opposite side, however, is the side where deposition begins to occur, because all the water is moving faster this way, so this side will be slower. So because it's slower, it's going to drop some sediment. We use an analogy of elbow, right? Remember, this is where you can drop your sediments. So the inside of the elbow is where you can drop the sediment. The outside is where more erosion will take place. So as a result, you cannot drop anything there. Your pen will fall off. All right. So if this is the elbow, this is where things will fall off, which is the erosion, the moving, things falling off. Then this is where things will be deposited, because this is the inside of the elbow. All right. Okay. Hopefully that brings some memories and simplifies what we see in there. So let's bring that to the question that we have here. So if the river was flowing fast, it's going to come straight and head on to W, causing erosion around that neighborhood. All right. and then it's going to bounce off and then come back and move on that way. So as a result, it will be slower here, causing deposition around here. So you see it's going to drop all of those sediments here. So this becomes deposition. So let's revisit that question and try to answer it. Question number 65. Explain why the stream velocity and rate of erosion at the riverbank is greater at location W than location X. Simply put, right here, because location W is on the outside curve. Is on the outside curve of the meander. All right. Or you can also say, you can say the river or the water in the river. Let's be clear. The water in the river faces location W head on than location, what's the other location? X, I believe. Than location X. Easy breezy. Either of those wording would have given you your point accurately. Don't mind me, just trying to be accurate. Okay, let's move on. Question number 66 will be next. Oh my god. Question number 66. Easy breezy. Let's walk through it. We can do this. All right. Drawing of contour lines is really easy. Let's read the question first and then give a more detailed explanation, and hopefully that would guide us in tackling this. In all of that. And question 66 says, on the map in your answer booklet, draw the 20-inch, 30-inch, and 40-inch snowfall isoline. What are isolines? Isolines are lines that join places of equal value. Some examples of isoline are isobar, isotherm, contour lines. Isobar join places of equal pressure. Isotherm join places of equal temperature. Contour line join places of equal elevation. So if you go back to the packet, you see that an iso line has been drawn for us here, joining places of equal snow heights. So remember, the question says a lot of snows have fallen in this area. So there's shows snowfall. So that area is showing snowfall. So the snowfall is being measured in inches. So which means the places around this line, give me a minute, all right, the places around this line, this 10 line, those places are, the thickness of the snow around that line is 10 inch. That's what it's simply saying, because that line is showing places where the places that experience about 10 feet of snowfall. So the question is asking us to draw the same line for 20-inch, 30-inch, and 40-inch. So we're going to follow some rules here. I'm just going to quickly review those rules, and then it should be easy from there on. First, isoline join places of equal value. So you want to make sure that the line is joining a place of only one value. Only one value. So if you look at the one that was given to us, is joining places of 10 inches. So all of this area is 10 inches. So your 10 here, let me take that out. Your 10 here must come and join with the other 10s all around. Okay? You can only join places of 10 all around. So that's how you know you're correct, because it can only take and touch all the 10 all around. Okay? So the next guideline is isoline do not cross. So you cannot draw through isolines and cross. If the two isolines cross, that means the place is not equal value. If it's equal value, all the 9s should connect, all the 8s should connect, all the 10 should connect. 10 cannot come and cross 9. 200 cannot cross 2000, because 200 and 2000 are not the same. Hello. So isoline should not cross. Commonsensical. All right. Then contour interval, you know what isoline or contour interval is. Isoline passes between higher value and lower value. I would explain. Let's look at the one of 10. If drawn correctly, you see that isoline would pass on the other side, on the upper side to it. You see that it's a lower number 7, and then on the lower side of the 10 is a higher number than 10. So all the numbers outside of the 10 should be lower than 10. All right, let's verify that. 9 lower than 10, 7 lower than 10, 9 lower than 10, 5 lower than 10, 9 you get the point. Everything outside of the 10 is lower. In the same way, everything inside of that 10 line should be greater. So 18 greater, 14 greater, 30 greater, 15 greater, 27 greater, 43 greater, 30 greater. You see, everything inside is greater than 10. Does that make sense? So the isoline has to pass through the middle, separating the lower numbers from the higher numbers. That is what, or that's how they drew that 10 line. So I think those are basically the major rules that we need to follow. So let's answer the question. We need to draw for 20. So let's guess, where do we think 20 would be right now? I see 20 right here. So I see 20 here. So I'm going to start connecting from this 20. I'm going to connect the next 20. All right. And then I'm going to keep going. And I'm going to connect the next 20 around here. And the next around here. Why am I bending it that way? Because everything inside of the red line I'm drawing should be greater than 20, because I'm drawing the line for 20. So I'm going to write 20 right there. I'm drawing the line for 20. So 32 is greater, 25 greater, 24 greater. That's why I have to include 24 inside. And I'm going to push 17 outside of it, because 17 is less. 18 is less, so 18 is going to be outside. 14 is less also. So I'm going to continue. 33 is greater, 22 is greater, 18 is less, so I'm going to go in between, taking 18 outside. 14 is less, so I'm going to keep 14 outside. 30 is greater, so I'm going to meander in between. I'm going to keep 15 outside. I'm going to keep 27 inside, and then I'm going to keep 19 outside because it's lower. And when done completely, I need to double check if I'm correct. All the numbers inside the red lines, are they greater than 20? Check. Boom. Correct. All the numbers outside of that, are they less than 20? 14, 18, 17, 17, 19, 15. Boom. I'm correct. So I've drawn my 20 line. Next, we're going to draw for 30 line. So I'm going to look for the figure 30 right here. And I'm going to do same thing. I'm going to connect. Is there any other 30 I need to connect to? No, but this is 33. So I'm going to draw this, and I'm going to keep that 33 inside in that manner. Remember, isolines do not touch. See carefully. I did it so that both of them do not touch. All right. So I'm going to keep going that way. I'm going to keep all the higher numbers inside, and then all the lower numbers should be outside. Careful, Kennedy. I'm going to keep going. All right, I'm going to keep that outside, keep 27 outside because it's lower, and I'm going to keep going and come back to 30. That's it. If done right, all the numbers inside should be greater. Boom, 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 boom. That's it. All the numbers outside should be less. 27, 25, 22, 23. Boom. All right, and I'm going to write 30 on it. Cool. Next I need to draw is 40. 40, 40, 40, 40, 40, 40. I can't see the specific number 40, so I'm going to guesstimate. So 40 should be something between 33 and 48. So it's going to be something in between there. So I'm going to follow that and go something like, remember 43 is greater, so I'm going to include 43 on the inside. All right, 33 is less, so I'm going to keep 32 outside, and I'm going to carefully hope I made it, and boom. Excellent. Hey, you see, oh come on, I deserve a drink for that. Come on, where's someone buy me a Coke? All right, you see, cool, that's it. And I'm gonna write 40 in there, and that's it. Cool. All right, and we've done question 66. Now we're moving on to question 67. Question number 67. Let's read the question. Question 67 said calculate the snowfall gradient between location A and B in inches per mile. Interesting. So we are calculating gradient. What do we know about gradient? We can find the formula for calculating gradient on our earth science reference table, page number 1. So I'm going to quickly flip that around so I can show you how I'm working my answer out. All right, gradient right here. This is the guy we are looking for. All right, that's the formula that we want to use. Change in feet value over distance. So change in feet value simply means the 2 points that you are trying to calculate, what are their values. So let's go back to the question. The question said the gradient between location A and location B. So let's go back. So I see location A right here. Let me use a different color. I see location A right here, and I see location B here. So what's the value for location A? 17. What's the value for location B? 53. So I need to find the difference. All right. So gradient, let me do the calculation here so it's easy for everyone to see. Gradient is equal to, let's look at the formula again, change in field value. Field value, so the difference between A and B. So I'm going to subtract B, I'm going to subtract A from B because B is higher, and I'm going to divide that by the distance. All right, so this is going to be equal to B is 53 minus A is 17 divided by distance. So what's the distance between A and B? How do I calculate the distance? I'm going to take scrap paper and I'm going to put it on my map. So you may not see this clearly because I'm recording the screen, but I'm going to do my best here. So I'm going to mark B, then I'm going to mark A. All right, so once I have those two markings, I'm going to take it to the scale at the bottom. All right, I'm going to make sure that one of the markings is at 0 and the other one, whatever the value is what I'm going to read off. So the value is about almost 10 miles. It's almost touching that 10 miles right there. So I'll say 10 miles. All right, so finally this will be equal to 53 minus 17. 53 minus 17 equals to 36. So this is equals to 36 divided by 10. So my final answer should be 33 points. Final answer should be 3.6. All right, 3.6 feet per mile. All right, cool. That should be our final answer. Easy breezy. That's how you use. That's how you calculate the value. So I'm gonna put that in there. 3.6 inches per miles. The value is already there. Sorry, the unit is already there. All right, last question for this first part of the video will be question number 68. Question number 68 says identify the name of the New York landscape region where the greatest amount of snowfall occurred. So looking at that map, where is the greatest amount of snowfall? Where's the greatest amount of snowfall? Let me choose a different color, maybe blue. I think it's somewhere around B, location B. Location B has the highest. Location B has the highest. So location B 53. I can't see any number higher than 53. So that'll be the area. But that's not what the question is asking. The question is asking the landscape region. So once I hear New York State and landscape, where my mind goes to is ESRT page 2. So I'm going to turn this around so I can be able to read that page effectively. So this is my ESRT page 2. All right, what you say, generalized landscape of New York region. So how can I tell which of the landscape that location B is pointing at? Let me look for some clues around there. Oswego is close to Oswego, it's close to Watertown, and Old George. So it's between those 3 towns. So that location is between those 3 towns. So that means I need page 3 here. So I would move to page 3 to locate those towns and see where they are. Mr. Old George, I see you there. Mr. Watertown, I see you there. Mr. Oswego, I see you there. So the area that we are looking at definitely will be trapped in between those 3 places. So we are looking for that something around that area. So what am I going to do here now? I'm going to combine these 2 pages together. All right, if you look at that location that I painted blue now, where that has the highest amount of rainfall, is just right around that state boundary. That state boundary, the lines that has that continuous and then broken line and then continuous line. If you look at it in the key here, it says state boundary right there. Okay, so it's almost at that boundary. So I'm guesstimating the region. All right, so if I'm to take a proper guess, it would be something around that area. So my answer would be Tug Hill Plateau. If you want to be more accurate, you can do something like this and say I'm going to use a line here, obtain that line, and I'm going to draw that line from the middle here and draw it up and continue up. So it has to be something. All right, I'm using those 2 pages in conjunction. And then on the horizontal, it has to be somewhere around the boundary of Lake Ontario where it meets. Then I'm going to draw the same thing from Lake Ontario. I'm going to draw the same thing, and boom, again we are at Tug Hill Plateau. So that should be our answer. All right, because the question is asking what landscape region. That's what the question was asking. The question was asking what landscape region, emphasis on that landscape region. If it was asking what town, then we would have stuck with page 3 and then figure out what town could have been in there or what city could have been in there. So let's answer that question and call it a wrap for this video. So text, and boom, I'm gonna say Tug Hill Plateau, something like that. Hope I got the spelling correctly. Bingo, gentlemen, ladies, it's a wrap. I'll see you in the second part of the video. Bye.